When I started using Unreal Engine, I had no concept of coding or best coding practices. I learned almost everything through tutorials. And the problem with tutorials is they're always focused on one thing at a time. So it took me ages to understand how blueprints should be structured in a project. These are 5 blueprint concepts that feel obvious now, but took me ages to understand. I'm not an expert, but I'm just someone who's been using Unreal Engine, and these are what I feel would have helped me. 1. We have components. The first thing that really helped me was learning components. Now, a character is a base, but then components are where you contain logic. When I first started out, I put most of my logic directly into the player character, the enemy, or equipment actor. At the time, that felt natural, but it quickly became very clunky. Everything became a sprawling mess in the event graph, with having to duplicate logic from one actor to the other. It was becoming unmanageable. Components solved that. Health, stamina, interaction, attack, these can all be grouped into components. So instead of having to copy health logic into every character, you can simply attach the health component to the character. I could create a single component, implement the logic once, and then attach it to whoever I wanted to have the ability of health. Each actor owns its own behavior, but the logic is contained in a separate parcel, one reusable parcel. That did 2 main things for me. First, it massively improved the messiness of my blueprints, and second, it eliminated copy-pasted code everywhere. If I needed to change something down the line, I only have to change it once in the component and not go through every actor itself to change that logic. It reduces complexity and makes debugging much simpler. If your character has blueprints everywhere, try grouping them into components. 2. Interfaces. So interfaces are a great way to avoid casting everywhere. Early on, I was casting to specific actors all the time, and that creates very tight coupling. That's simple at first, but once things start changing and you start editing things, it quickly becomes a whole mess. Interfaces solve this by allowing blueprints to communicate without caring what class it is. At a basic level, it's just a message and a response. The caller sends a message, and if the recipient has that interface implemented, it responds. And if it doesn't implement it, nothing happens. A simple example is with a door. Imagine you have a button and it sends an interface message to the door. If the door implements that interface, it will respond, in this case, open. But if that same message was sent to a window which isn't meant to be open, then it won't open. I think that's clear. The benefit is that your player then doesn't have to know about every door, every enemy, every character to be able to interact with it. It just has to know that it wants to interact, and then those other objects decide themselves what their response to interaction is going to be. It allows you to avoid hard dependencies between the actors. And because nothing's cast, you can then swap out actors easily without having to rewrite systems. The same pattern works for health, damage, UI, or whatever else. 3. Stop hard coding. Another problem I had when I first started was hard coding values. When I first started trying to implement systems, I was hard coding values directly into the blueprints. Stamina, speed, damage, straight into the blueprint graph. That's fine for testing, but the moment you need to change it, you need to hunt down the variables in the event graph. Most people know that replacing hard-coded numbers with variables is much better, but you can take that a step further. Instead of passing floats, balls, or anything else around, you can instead group them into a struct and pass that around as a single unit. Those structs can then be populated from data assets or data tables at the beginning of play, and it all happens automatically. So then instead of having to chase down which variable is what, you can just go straight to your data table. It keeps your data and your logic separate, which can make debugging easier, and also makes your system more scalable. If you're still searching through your blueprints for various numbers and variables, then try using this approach. 4. Delegates and dispatchers. When I was first building things, a lot of my logic was chained together. One thing would happen and that would cause something else, and then something else, and so on and so on. Events would trigger events, functions would trigger functions, and inputs would trigger events. That works initially, but as things progress, it becomes harder to follow along, especially as those execution chains grow. What helped was moving to an event-driven system. using delegates or event dispatchers. Delegates are what they're called in C++, and event dispatchers are what they're called in blueprints. So instead of having to constantly call other systems to check, such as through tick, you instead have the systems announce or broadcast when things have changed, informing the other blueprints that it's time to react. So they only react when something is broadcast. For example, a health component doesn't need to know how death works in a game. All it has to do is when health is below a certain amount, it broadcasts that the health has reached a certain point. Whoever is listening to that can then react accordingly, playing the death animation, stopping the inputs, and so on. Anything that cares about that death logic, that could be UI, sound, input, they bind to that delegate. This logic can work for anything, from stats such as stamina, to interacting with objects, to enemies observing. The point is, events only are called when they are called for. You set everything up once, usually in begin play, and then they only react when they are called. That removes giant execution chains, reduces dependencies, avoids unnecessary tick logic, and makes behavior much easier to predict and debug. If logic only needs to run when something changes, it should be using a delegate or event dispatcher. 5. Avoid ball branching. When I first started, I relied heavily on boolean branching. Who doesn't? It's a quick and simple way to get gameplay systems up and running. The problem is what happens as systems grow. Before long, you end up with layers of branches everywhere, and eventually the web of booleans becomes hard to manage and understand. And even worse, you can end up with conflicting states. For example, something like in air could be true, whilst in cover is also true. At that point, you're not even describing states or behavior, you're just reacting to conditions. What helped me was to stop thinking in terms of loose booleans, and instead start thinking in terms of states. Instead of lots of independent balls everywhere, you group them into logical states, into categories, which are mutually exclusive behaviors from one another. That could be done with enums or gameplay tags, or maybe another method. The exact tool doesn't matter as much as the key idea. The key idea is that an actor can only be in one state at a time, and all of the conditions should be subject to that. Now, you still have to design those states carefully, making sure that they're logically grouped and truly independent from one another in terms of values. But by having them grouped, it makes things a whole lot easier and much less cross-branching going on. Okay, so none of these are advanced, and I'm not claiming that they're best practice. These are just things that have helped me progress my projects forward. And I feel like if I had known about them earlier, it would have really helped me progress projects quicker. I think the mindshift fix that helped me resolve the issues was, instead of thinking of quick fixes, you instead think of the more overarching structure and architecture that underpins how your items communicate. Taking more time to set up usually saves you time down the road. Now, I'm still learning, but these changes really helped me improve my blueprints. Thank you for watching. Bye.